And there we have it. Okay. And so now we're going to move on and start our first live presentation. And this is going to be Chris Carson. So Chris, why don't you go ahead and unmute?
Yes. So my name is Christopher Carson. For the last dozen years or so now, I have been going around preaching in the ears of anyone who will listen and a much larger number who won't, about what people would call, I guess, a moon-first strategy for space development. If you're in an NSS chapter, you should have received recently a copy. I sent one to each of the NSS chapters, obviously not to each member of the chapters, a copy of the 2012 Canadian documentary Lunar. And I want to thank Joe, actually, our host today, for chipping in to help cover the postage on that, because as it turns out, you can run into quite a bit fairly rapidly in terms of postage doing that. And so hopefully once all of this is calmed down, maybe you might find it something interesting to watch at your chapter meetings. Obviously, it's not just about me. There's a bunch of people in that movie talking about the moon and their relationship to it. Peter Koch, longtime editor of the Moon Miners Manifesto. Rick Tumlinson, another person you may have run into over the years. And probably my personal favorite of the various interviews and segments is the one involving the late, great Alan Bean. I was very privileged to be able to go to his studio in the Houston area, because he was, anyway, for the interview, and see how he did his paintings. It's always marvelous to see the different aspects of people. In fact, we had Jim Lovell there in his study with all the books in the background. Whereas if you had Alan Bean, of course, it would be the paint. He had his beautiful, beautiful painting workshop. And he had the great big model of the limb. It was about this big, which he used, because the thing you have to understand is he was trained first and foremost in engineering. And so he became a painter later. But as an impressionist painter, he still insisted on getting things technically correct. So the sight lines, the perspectives, and so on were all set up ahead of time using precision grade drawings. And then he would paint his impressionist style paintings, which I thought was just a marvelous thing. In fact, while we were there for the interview, he had a phone call from somebody who wanted to commission him for a painting. And he was telling the person, no, I'm not going to do that. And from listening, just from overhearing, not that I was eavesdropping on anyone's phone call, but we were in the room, he was talking on the phone, and I could tell by listening, the person wanted to do some kind of a painting where you could see, where you're with the astronauts on the lunar surface and you could see the Earth in the background. And he was having to explain to them, no, we can't do that, because there wasn't any of the landing sites. The landing sites were all towards the center geographically of the moon. And so the Earth would be nearly vertical in the sky. And he talked to him for a little while and then said, all right, well, for Apollo 17, we can sort of fudge it because there was a big hill, because we were in the, it was because they were in the valley of Taurus Litra. There was a big hill, so we can sort of, and they were more towards the margins, so we could sort of get the Earth into the picture. Anyway, I just love that about him. That he was, here he is with the easel and the smock and, looking like somebody's grandpa, who paints, looking, and then he's having an argument with somebody about the alignment of the planets and how he's not going to do the painting that the person wants and wants to pay him to do because that would be wrong. So that was something I absolutely loved. And that unfortunately doesn't show up in the film, but it's an interesting enough film to watch, even if you ignore my part of it. And that's really why I had the idea of sending out copies to the various chapters. Enough about that. And so what do I really have to say here? Well, the line that everybody remembers, I think, from Apollo 13, if you say Apollo 13, what do people immediately come back with? The thing that everybody remembers, I think, is failure is not an option. Well, I'm going to turn that around back on you for a minute. Let me do this. Failure is not an option. It's inevitable. If you dare to do great things, if you try to do difficult things, you're going to have failures. Targets are going to be missed. Objectives are not going to be reached. Money is going to be wasted. People will be hurt and even die. What we always forget is the exact same thing will happen if we don't dare to do great things. When I think of that in the context of the Apollo program, for example, you know, NASA, Pete Conrad, who was, he was a character. Everything I know about him says he was a real character. Pete Conrad wanted to do a mission he called it Gemini 12A because 13 was an unlucky number. Who knew? Gemini 12A would have involved something similar to what they did on other Gemini flights, where they docked the capsule with an Agena spacecraft and boosted into a higher orbit, except he wanted to use a Centaur spacecraft and go around the moon. Now, it wouldn't have been able to go into orbit. It would be a free return trajectory, the same kind of trajectory that Apollo 11 and 12 used for translunar orbit insertion. They wouldn't have been able to orbit the moon, but they would have swung around it and come back to the Earth. And that would have given, you know, again, as Captain Lovell said, people seeing the far side of the moon, people seeing the Earth from a distance where you could cover it up with your thumb. That was very daring. NASA did not want to sponsor that mission because there was too much of a chance of something going wrong and people being killed. Well, as I said, we don't have any choice about that. It's going to happen. Because what happened instead? We had the Apollo 204 fire. What were Grissom, White, and Chaffee training for? They were training for a mission. They were preparing for a mission that didn't have any mission in it. The Apollo Block A command and service modules had already been rejected for use for lunar flights. There was no docking adapter. There was just too much wrong with them. Really, the only objective of what became retrospectively known as the Apollo 1 flight was to do a flight, to go into orbit around the Earth and demonstrate that the US hadn't dropped out of the space race, because they weren't going to be using basically any of the hardware or demonstrating very many of the systems that were going to go into the actual lunar mission. And they died in this sort of pointless way because nobody had bothered to anticipate that a crew in a capsule on a pad with an unfueled booster might be in danger from the spacecraft itself. Nobody had anticipated that they would have to get out in a hurry because there was this long chain of steps that came up to that point. Similarly, Apollo 13. Nobody had asked the question. You know, they trained for all kinds of contingencies, right? They prepared for all kinds of contingencies, but nobody had asked the question, what happens if we lose electrical power to the CSM after translunar orbit insertion? If they had asked that, if they had, as Captain Lovell said, thought a little more seriously about what it would mean to use the lunar module as a lifeboat, they would have realized, duh, we need to make the carbon dioxide absorbers the same in the two spacecraft so that we won't be trying to use maps and duct tape to make the square and the round fit together. Now, what does this have to do with my alleged topic, which is the future of the moon, future moon missions, etc.? Well, one of the things it has to do with it is we can anticipate a lot of failures, all right? I mean, I was looking at an MIT Tech Review article, the 17 most important moon missions between now and 2024. Right, because NASA's current program of record has in it a human lunar landing in 2024 as part of the what's now called the Artemis program with what's now known as the Space Launch System. Well, is it really going to happen? NASA programs of record have a tendency to change in a kind of whiplash manner. The folks working for NASA with every good intention, can't do much if Congress and the president pull the rug out from under them. That's just a fact. And it's happened over and over and over again. I mean, back in 2009, the Augustine Committee hearings, I was there in Houston, Sally Ride comes out and says, well, the Ares-Orion program is slipping 18 months a year. Not exactly encouraging news. And so the thought was, well, we're going to have to scrap this and start over. Because, of course, the whole thing with Ares-Orion from the beginning was, they said, well, we are going to use a bunch of stuff we already have, Apollo stuff, space shuttle stuff, and it's going to go together rapidly with low technical risk. And somehow we still don't have a working spacecraft and launch vehicle out of that. And it's just not looking great. And I'm not trying to be a pessimist here. I'm saying we've got to ask what kinds of failures we're willing to tolerate, because a lot of the things that have been announced aren't going to happen. We can say that retrospectively, a lot of the things that have been announced over the years haven't happened for one reason or another: loss of commercial support, loss of government support. On the other hand, there's a bunch of things that are happening, right? We're looking at commercial crew in the very near future. We already have commercial resupply services to the space station. That's big news. But the result is we've got a bunch of different puzzle pieces, and none of them exactly fit together to form a picture. It's like we've got pieces of half a dozen different puzzles which have been dumped into one box and shaken. And if you've ever been a jigsaw puzzle person, your head is probably exploding right now when I say that, right? But we have a lot of people talking about different scenarios, and there's not a lot of coherent vision, right? I mean, we've got people, for example, talking about a lunar land rush. They're talking about polar ices, Shackleton crater, Helium III. I'm sorry to say, even Harrison Schmitt has gotten on board with that last one. And all of these, they're puzzle pieces, and it's hard to see how they fit together. What do I mean when I say that? Well, for example, you talk about polar ices. Polar ices are very valuable if you're going to the moon to stay, right? That's my deal, right? Settlement first. That's been my proposal from the beginning. We should focus on settlement. But if you're not doing that, what do polar ices buy you? Well, they can be made into propellant for spacecraft to do other missions, which already assumes a commitment to two things, right? Other more ambitious missions and buying propellant from somebody. Helium 3 is even worse, right? Helium 3 is a rare isotope of helium. It's rare on Earth. It's slightly less rare on the moon. You can get helium gas out of the surface regolith, but it's still far more than 99% helium 4. In order to get helium 3 out of it, you have to do isotopic separation, which, if you ever ask anybody who worked at Oak Ridge, is a really difficult problem that requires an enormous amount of industrial plant, all right? So the idea that we're going to be shipping gas centrifuges or gaseous diffusion plants to the moon in order to produce helium-3 is fairly unlikely when you realize helium-3 is mostly what is a fuel for fusion reactors that don't exist yet. Again, it's not just chicken and egg. It's not just putting the cart before the horse. We've got a cart here, and no one has domesticated the horse yet. So saying that we're going to go to the moon for helium-3 or even for propellants it assumes a lot of things that aren't there right now. Now, there's been a lot of talk recently in the National Space Society particularly, because the Planetary Society, and in practice this means Lou Friedman. And I have nothing bad to say about Louis Friedman personally, all right? I want to make this very clear. He's come out very strongly with the position that any SLS-based lunar mission, any Artemis program lunar mission, should be a flags and footprints one-and-done thing, and then they should move immediately onto Mars. Now, there's some consternation about this, in part because everybody really needs to admit that Mars is hard, all right? Unmanned missions to Mars have a fairly limited track record of success. Manned missions to Mars would be much more difficult. It's hard to see how that comes about. All right, fine. But here's the thing. Within his terms of reference, Friedman is right. It's not what I would want, but he's right. And why is he right? He's right because the SLS isn't intended to support more than 2 launches a year, 4 at a maximum. You can't do anything other than one-and-done flags and footprints sortie missions with a booster that only supports 2 flights a year. No matter how big it is. Yeah, if you start talking about something really ludicrous like the old Sea Dragon concepts, or, you know, ground launch Orion, fine, that's fine. You start blowing up atom bombs to throw cargo into space, you can talk about things that are as big as you want. But honestly, anything sustained requires something continuous. And so look, I've for some years now been writing up a position paper talking about how we could do a lunar settlement pioneering mission with existing launch capacity, existing spacecraft, things that either already exist or can be prepared with fairly small investments and time challenges. And I really think it can be done, but it relies on this concept of fairly frequent flights. And so, you know, lots of people are talking about the moon now. This is the New York Times Sunday supplement from a few months back, you know, talking about the next giant leap, 50 years after Apollo 11. The full story of our relationship to the moon has yet to be told. If you've picked up one of the last few issues of Wired magazine, they're talking about space food, space this, space that. That's great, right? Space consciousness is great. It means that people are getting ready to have the mindset that they need to dare great things and also to dare little things, because eventually, right? Eventually, our objective is not just to take the American flag or the flag of the United Nations and plant it, you know, on all the moons of the solar system and go home and just sit on our duffs, you know, self-isolating on the Earth, right? That's not where we are going. I believe when we look at the vastness of the universe, that we have to accept the only reasonable future is the O'Neill future. The only reasonable future is the future in which people are everywhere. Earth life radiates outward in the cosmos. The things that we as humans do, we do them, all right? And that takes a mindset which is willing not to just dare the big things where failure could kill you, but it's also there to dare the little things. I guess the best thing I can say is nobody has an Australia program. You know, for a while there, 200, 250 years ago, the British government had an Australia program. They had ships going to the Antipodes, the place which is opposite Great Britain on the globe, in order to see what it was about, and coming back and, you know, all sorts of things like that. And they had some catastrophic mission failures, like the mutiny on the Bounty. All right. And then, but now, nobody has an Australia program. People live in Australia. You want to go to Australia, you don't have to go to the National Australia Administration and apply to be an Australianaut and spend 6 years in training, right? And you got your Australia suit and they put you on the Australia boat, which is gonna go across the Pacific Ocean, starting from San Francisco, cross the Pacific Ocean, cross the equator, cross the international date line, and you get there and it sinks, right? If you get off it and it sinks and you can't go back. This is not what happens. You go to your local airport, or at least you did 6 weeks ago, and presumably a month or two from now you'll be able to do that. You go to your local airport, you put the money on the counter, you say, 1 ticket for Australia, please. And after they've done frisking you because of the weird accent you're using, you get on the plane and you fly to Australia. And the Australians say, you forget your passport. And then you've got to go home and you've got to get your passport and come back. But, you know, it's not that big of a deal. And we have to get to that point where we're not talking about the mission anniversaries of the Artemis flights. And I'm sorry, I'm sorry, Anita. I'm sorry, Janet, okay? Because I think that's actually a dig at something one of you said the other day. And I'm sorry for doing that. But
okay, well, we're going to have to
get away from that. We've got to get to where this is something that's not seen as an unacceptable risk. It's seen as something we do every day. And so that's about all I have to say about that. And then there'll be some Q&A, I guess, if I haven't completely blown out the time.
Can you hear me, by the way?
Yeah.
Okay, great. So we were talking about me having to call you, but we don't need to if you can hear me. Questions and answers. We have a couple of questions. Let's see, we have one question. Let's see, we have a statement from Bennett Rutledge. by going there with the mindset that this dust wad, my home it is, and being prepared accordingly. Not sure, you'll have to explain that one to me, Bennett. I'm not quite sure I understand it. We have another one from Tapaswini Sharma. Can this be possible with the current technology? Can we possibly create a system of rovers and satellites that would help us know better? So when a rover goes out of contact, another would let us know why. Can you answer that one?
Okay, so there has been a lot of talk over the years about, let's say, lunar communications satellites. And it's a very realistic prospect. As a matter of fact, you may remember that some of the Apollo missions did in fact deploy what they called sub-satellites from the service module. They were hidden behind a panel in the service module and kicked out into lunar orbit. The proposed Apollo 18 far side landing mission would have needed, of course, a relay of some kind to maintain contact with Earth. And so there's no great difficulty in this. The question is, what kind of orbit do you want to use? And so there are several candidates. For my money, the best place to put relay communication satellites is what's known as an L1 or L2 halo orbit. And these are, so in the Earth-Moon system, there's sort of 5, we'll call them points, although that's not exactly.
We don't want to, I'm going to interrupt you just for a moment because we'll have to assume that people know what the Lagrange points are rather than trying to define it at this point because you only got 5 minutes.
Right.
So just a quick summary.
Quasi-stable points where you can put a satellite and it will remain in roughly the same place in the Earth-Moon system as all the pieces move around. And so from the L1 point, which is between the Earth and the Moon, you can see basically the whole lunar near side. From the L2 point, which is on the other side of the Moon, you can see basically the whole lunar far side. And with these halo orbits, which are sort of in the same plane, but they sort of drift around these points, you can actually see the fringes and you can communicate or sort of around the edge of the Moon.
That's a good answer.
So that's, for me, is a real great place to put not only communication satellites, but also power beaming satellites, which can allow you to do things on the surface. For example, with not just small rovers, but big mobile bases. If you can deliver 30 or 100 kilowatts of continuous electricity from a power beaming satellite, and I can tell you right now, based on the all-electric ComSats that Boeing, among others, has been deploying, based on the lift capacity of the Falcon Heavy, based on the work Jordan Kerr was doing before he passed away on power beaming with infrared lasers, that appears to me to be completely feasible. And so either for an early lunar stationary base or actually later on for mobile bases, we can definitely use satellites not just for communication relay, but also for power purposes. Because of course, on the surface, unless you're at one of a couple of very favorable positions, you've got 14 days of darkness where your solar power doesn't work. And in the old days, we assumed that a nuclear reactor would cover that, but politically these days, that's a bit of a difficulty. And technically it has some difficulties also, just because nobody has flown a space nuclear reactor in over 20 years.
Right, I'm gonna stop you there because frankly, we need to move on. That was a great answer. By the way, our particular chapter is hopefully known as promoting the use of a laser in at L1, L2, and then lunar orbit to power the surface during the 2-week-long lunar night. We've written detailed articles about that. So moving on, thank you very much for that input, Chris. And now I'm going to ask you to go on mute